The EOQ total cost formula is a tool for finding out the total cost associated with any order size. Of course, first you have to collect the relevant data. Let's take a look. Suppose we must secure 8,000 of some stock keeping unit annually. Right away I have found something I need. Capital D is annual demand. In all of these inventory models and the formulas, capital D is annual demand. Annual demand, how much we will need in a year. Oh, okay, now, right, you can see that is featured right here in the formula, but wait, there's more. At a cost of, okay, interesting. We've got to secure some SKU, stock keeping unit, some certain item, 8,000 a year, and they cost us $10 each. And I am interested in that piece of information, but you know, it doesn't go down here in any particular place. It costs us $30 to place an order. Now that I recognize right away, especially since it says regardless of its size. That is capital S, the fixed cost associated with an order. Okay, we estimate our inventory holding costs to be 30% annually. That is another very interesting piece of information. But you know that there's no place to put in a percent down here. Sorry, let's just hang on to that. What would be the, okay, what would be the annual cost of a fixed order size of 2,000 SKUs? Notice the question. The question is, what if we order these things 2,000 at a time? All right, now, in order to determine what the annual combined ordering and holding costs would be of ordering these things 2,000 at a time, we just need to fill out the formula. And you can see that we have found most, but not all of it, because we have D, we have Q, we're testing 2,000, that's what they asked, we have S. The only thing that we lack here is H. Oh, and it pays to note what H is, because it's a little weird. H, right here, is the cost of holding, that's what the H is for, 1 unit of inventory for 1 year. That's that right there. Now, you might be thinking, well, why on earth would I hold one of these things in inventory for a year? It doesn't matter. We just need to know what it would cost if you did. Well, it didn't say that in particular anywhere in the little scenario, but it did tell me enough information to figure that out. That's what this was. And a lot of firms do express their holding costs this way. Here is what the unit is worth. This is how much money they sunk into it. They estimate their annual holding cost to be some percent of its worth. So in our case, H would equal the original $10 you spent on the unit. You'd take 30% of it. Oh, H is, and I'll put a dollar sign there, a currency sign there, because this is a cost. Oh, it would cost us apparently $3 to hold one of these things in inventory for a year. Okay, finally, now I have what I need just to answer the question, because I fill out the formula. Okay, the total cost of ordering these things 2,000 at a time is 8,000, because that's D, divided by 2,000, because that's the Q that we are evaluating, times 30, because that's S, plus 2,000, that's the Q that we're looking at, divided by 2, times 3, because that's H. All right, now in my scratch work, I get that this whole part in here is $120. And then this, 2,000 divided by 2 is 1,000 times 3. I mean, this is obviously $3,000. We're not concerned with these two parts in particular. We are concerned with their combined result. There is the answer to our question up above. What would it cost to order these things 2,000 at a time? It would cost us a total of $3,120 a year in the combined ordering and holding costs. Oh, okay. Now, question answered. Now, notice that this particular formula is you can use to evaluate any order size. Okay, it just asked about 2,000. 2,000 isn't necessarily a good order size. In my notes, just to experiment, I picked another order size. I said, well, what about Q equal 500? Okay, and I'm just making this up. What if you cut down the order size and you only ordered those things 500 at a time? How much would that cost? Now, check me on this. I got that it would cost a lot less. $1,230 a year, which is considerably less than $3,120 a year, which means that we would assume that this firm, whoever they are, would prefer to order them at least 500 at a time versus 2,000 at a time. But anyway, I added that part. That's not what was asked. What was asked is just how much would it cost to order them 2,000 at a time. We have that answer. Now, we have that answer. It's that simple. Fill out the formula. If you understand how the formula is working, so to speak, you can actually answer a lot of questions about that policy using just this one formula. Okay, now what do I mean by that? It gets down to the why. Why is that the formula? All right, now you can see here we've got some grid paper because we're going to channel another tool from this chapter, the idea of a sawtooth diagram, just a line graph of inventory levels over time. Okay, because there's this order size, right? And in our example, we'll go back to the original example, that order size was 2,000. If you were using this order size, what would your inventory levels look like? Well, one assumes at some point you'd have 2,000 delivered, right? So your inventory levels would be here. Now, here's an important assumption of all of these particular types of inventory models. I am drawing a straight line that is drifting down to 0, which is to say running out, because we assume that demand is constant, right? That you're using up or selling or giving away the basically same amount every day. Oh, but when you run out, one assumes you'll get more, right? Which means your inventory level would go back up to 2,000, and then it would drift down again because you'd use it up, and then you'd get another one. And see why they call them sawtooth diagrams? Because each one of these teeth represents an order cycle, right? Ordering 2,000 and using it up. The area of the teeth represents the inventory burden, how much stuff is sitting around. Oh, meaning that if I were to try to graph, and I just kind of have to freehand it here, my suggestion of 500 at a time, notice that 500 would be more like here, and those would be considerably smaller teeth. When you drew that, there's much less area, so to speak, to ink in here. Oh, right, because inventory dynamics. The smaller the order size, the lower the inventory levels. The greater the order size, the higher the inventory levels. Oh, now you might have, yeah, you notice this, you're drawing this, and actually here's the much prettier picture of the same thing from the book. Yeah, okay, I was drawing it just to talk through it. Now, wait, why are we taking the side journey? Like, what are some other questions that I could answer about this policy using the same formula, not needing an additional formula? Okay, well, there's a little room to work down here at the bottom of the note sheet. We can get more answers from one formula. There's the same old formula. Oh, wait a minute. First off, notice that the formula is in 2 halves. And you could see that from my scratch work. I said this half right here was 120, and that half right there was the 3,000. Right, this is annual ordering costs, the first half. If somebody asks you, if you order these 2,000 at a time, how much do you pay in that $30 fee? What are your annual ordering costs? That's the 120 versus annual holding costs. Oh, so if we order these 2,000 at a time, we're going to spend considerably more on holding costs than on ordering costs. That's the 3,000 versus the 120. But right away, we have some more insight into this particular policy. Now, wait, that's just those 2 halves, what they mean. Look inside those halves. This was the ordering cost. This right here, block out the actual cost per order. D divided by Q is the number of orders annually. So if somebody said, okay, you order these 2,000 at a time, how many times a year are you going to order? Actually, it's just kind of common sense. You need 8,000 over the course of a year, and you're going to order them 2,000 at a time. We'll order 4 times a year. But there, that's that question answered. Versus, oh, now this one's easy. Maximum inventory, you can see that. from the graph, both my hand-drawn one and the pretty one right here, maximum inventory is just the size of the order. So if we're still analyzing that policy where you order them 2,000 at a time, the maximum inventory level would be 2,000. Why would you ever want to know that? Probably because you're organizing the warehouse. So you want to know what is the most amount of space that we're going to need to store this, right? Well, it's going to peak out at 2,000 right when we get in the new order. Now, next question below that one, average inventory. Go back to the formula. Block out the H. The average inventory is what's left, Q divided by 2. So in our case, for this policy, that's the 2,000 divided by 2. So, oh, by the way, if we order these things 2,000 at a time, we will have, on average, about 1,000 of these things sitting around at any one given moment.